All right, this is video 6 of Unit 4. And in this video, we'll talk about writing chemical equations. Remember, chemical equations are representations of chemical reactions. So, for example, when water is broken down into hydrogen and oxygen gas, you can represent that with a chemical equation. You can balance the equation to make sure you see we have twice as much hydrogen as oxygen. So we're going to write these essentially from scratch. That's going to be the topic here. Okay, so we'll just dive right into it. And the first one here asks us to write the equation for zinc metal combined with aqueous hydrochloric acid, producing hydrogen gas and aqueous zinc chloride. So the first thing to think about is which word here represents the arrow, because remember, our reactants are separated from our products with an arrow. And this word produces is going to be this arrow. So right before this, we have our reactants, and after that, we have our products. So zinc metal, we write that just as zinc, like so. Now, because it's a metal, what we'll do is we'll put a little S in the as a state symbol, because if it's a metal, it's a solid. Remember, you have solid, liquid, gas, and then you have something called aqueous for your state symbols. Those are the four possibilities. Okay, so in this case, we have zinc metal combined with aqueous hydrochloric acid. So combined with will be represented by a plus. That means we're adding zinc metal to hydrochloric acid. Now I give you the formula here for acids. We didn't really learn how to write acids, so go with that. And then it does say aqueous, so let's go ahead and put a little AQ behind it. Let me make a little bit of room here, and then in parentheses we'll do AQ for the state symbol. Okay, now it says it produces hydrogen gas and aqueous zinc 2 chloride. Okay, how do we write hydrogen gas? Well, you're tempted just to write H, but remember, H is one of the 7 diatomic elements. Remember the 7 diatomic elements on the periodic table, there are 7 of them. That's nitrogen, oxygen, fluorine, and then chlorine, bromine. That gives you 6, and then iodine actually gives you 6 here, 1, 2, 3, 4, 5, 6, and then the last one is hydrogen. So hydrogen is one of the 7 diatomic elements, which means when you write it, you have to double it up. Now these are when they're by themselves. You don't do it here because hydrogen isn't a compound, but you do it here because it's by itself. We know hydrogen is a gas. It tells us that here, but so put a little G as a state symbol. And your second compound would be aqueous zinc 2 chloride. Right? Zinc 2 chloride is actually an ionic compound. So we have to recall how to write zinc 2 chloride. So the zinc would team up with the chlorine for a compound, to make a compound that you'll write in here. Now the 2, remember, represents the charge on the zinc, so you'll put a +2 there. On the periodic table, chlorine is sitting in group 17. It has a -1 charge, so you put a -1 there. So we can see that we require 2 chlorines for 1 zinc when we write the compound. So our compound will be written as ZnCl2. Now it says it's aqueous, so let's go ahead and put a little AQ as a state symbol in there, and the equation is written. Last thing we have to do is balance the equation. And so you've practiced this a little bit, and you see we have 2 hydrogens on the right, so put a 2 here. That gives us 2 chlorines. Yep, that's 2 chlorines, a zinc and a zinc. The equation is balanced. This is our balanced equation for the reaction represented above. Not too bad. All right, why don't you try one on your own? Go and practice this on your own. Pause the video and try this one. And then let's do one more. Let's do this one. Write an equation for solid copper 2 carbonate decomposing into solid copper 2 oxide and carbon dioxide gas upon heating. Right, in this case, what we have is, again, the word, let's pick the word that represents the arrow. Now this is a decomposition reaction, so decomposes will actually be the arrow here. So we have one substance on the left, solid copper 2 carbonate. Now this is a compound, and it uses this polyatomic ion carbonate that we saw in the previous video, which we'll kind of cover here. And then you have solid copper 2 oxide and carbon dioxide gas. So we have one reactant, and then we have 2 products, this one and this one. So we'll kind of write the equation like this. We'll have a reactant and 2 products. Okay, so in here has to go copper 2 carbonate. How do we write copper 2 carbonate? Well, the 2 represents the charge on the copper. That's a +2. And the carbonate was that polyatomic ion. Now, if you cycle back in your notes, you'll see that the polyatomic ion carbonate has this formula right here. Whoops. Let's try this right here. Apologize. Here's carbonate. Carbonate has a CO3 with a -2 charge. That is the formula for it. So let's go ahead and put that down. That's really, you can just go ahead and look up the carbonate. You don't have to memorize it. And so our carbonate is actually CO3 with a -2 charge. Now what you'll notice is that copper is +2, carbonate is -2, so you just need one of each. So whenever you write the compound, it'll be CuCO3. That will be the compound that you write. Okay, it says it's a solid, so let's go ahead and put an S as a state symbol behind it. And then it decomposes into solid copper 2 oxide and carbon dioxide gas upon heating. So copper 2 oxide will be Cu. Let's see, we have to think about this as a compound as well. We have to write it as a compound. So your copper has a +2 charge. Oxide is oxygen. If you look in the periodic table, that has a -2 charge. So again, we just need one of each. So copper 2 oxide will be written like this, CuO. It says it's also a solid, so we'll put a solid here. And then we're going to add to this carbon dioxide gas. And then we hopefully remember that carbon dioxide gas is CO2. Di means 2 oxygens for every 1 carbon. And this is a gas, so we'll put a little G as the state symbol behind it. All right. And make sure the equation is balanced. If you take a look, the equation is balanced. There's 1 copper on the left, 1 copper on the right, a carbon, 3 oxygens on the left, 1 here and 2 there. Yeah, the whole thing is balanced. So the equation is complete. Go ahead and try the same thing on your own and practice 10. Pause the video, try it. And then we'll finish up with an example that has 5 different equations for us to write. And this is the toughest part of writing equations, and that's completing the reactions. In order to do this properly, what we'd have to do is actually predict what type of reaction this is. So we have to go back and remember our synthesis, our decomposition, our single replacement, our double replacement, and our combustion reactions. So we're going to first predict which of these 5 this fits into, and then we can write the products. All right, so the first one, I have 2 elements being combined. Now, if I have 2 elements being combined, then most likely I have a synthesis reaction. Really, that's the only thing that can happen is they can combine together into a compound. And so this is going to be a synthesis reaction. So I'm going to write the compound between potassium and oxygen on the right side. Now you'll be tempted to simply put these together and write it as KO2, but this is incorrect. This is wrong. The reason why it's wrong is because the charges have to be balanced when you write potassium and oxygen. What you have to do, like we did before, you have to think about what's the charge of potassium, what's the charge of oxygen. Well, potassium is +1, oxygen is -2, so you would require 2 potassiums for every oxygen. So the way you write this compound is K2O, not KO2. Now you may be saying, but how about, looks like we gained some potassium, we lost some oxygen. Well, that's why we balance the chemical equation, right? So at the end of it, you can go ahead and put a 2 here to balance the oxygens. That gives you 4 potassiums, put a 4 here, and we're finished. So that's your synthesis reaction. How about our decomposition reaction? Well, with decomposition, we have a compound that's going to be breaking down into elements. So I'm going to split up sodium and chlorine apart from one another. Here they're in a compound, then they're going to become elements. And I'm going to simply write sodium plus chlorine. So notice I've split them up. Now you have to watch out because chlorine is a diatomic element. You have to put a 2 down here. Remember, this is one of the 7 diatomic elements. You don't have to do that for the sodium. Sodium is not a diatomic element, but chlorine is. Also, before you leave, go ahead and balance the whole equation. So it looks like I have 2 chlorines here, so let's put a 2 there. That doubles my sodiums, and that's a 2. The balancing portion of this will be not too difficult most of the time. That's our decomposition reaction. Next is our single replacement reaction. Remember, single replacement, you have an element that will come in and replace a similar element in a compound. Now here, calcium is a metal, and so it will replace the metal chromium. Chromium here is a metal, so calcium will replace chromium. So chromium was with chlorine. Now calcium will be with chlorine, and chromium will be on its own. Essentially, they swap places. So what you have now is you have chromium by itself on the right side, and on the left side you have calcium chloride. Now you're tempted again to just stick the calcium in there and put 3 chlorines with it, but that's not correct. We have to think about the charges. So we have to go back and say, all right, what is the charge of calcium? Well, on the periodic table, calcium has a +2 charge. Chlorine on the periodic table has a -1 charge. So I need 2 chlorines for 1 calcium. So my compound should be written as CaCl with a 2. And then I can balance the equation. Since I have 3 chlorines here and 2 here, let's get them up to 6. Put a 3 here, that gets me up to 6. Put a 2 here, that gets me up to 6. I have 2 chromiums now, let's put a 2 here. I have 3 calciums on the right, let's put a 3 here, and the equation is balanced. I'm balancing these really quickly, so you'll obviously stop and make sure you can balance them. All right, how about the next one? The next one will be a double replacement reaction. Here we have silver and barium, and these two will actually swap places. Silver and barium will change places. That's how you know it's a double replacement. You have 2 compounds reacting with each other. All right, so when they swap places, you'll have barium nitrate and silver chloride. And then again, we have to balance charges. I can't assume that when the silver comes over here, AgCl2, I can't assume that. I have to think about the charges. And in fact, the charges are going to be +1 and -1. So silver here has a +1 charge. Here's how I know silver is a +1 charge. Nitrate, NO3, is a polyatomic ion. And if you go back up to the previous lesson, nitrate, here it is, there's nitrate. Nitrate, notice, has a -1 charge. So this whole NO3 has a -1 charge on it. So since it has a -1 charge, silver on this compound has a +1 charge because there's only one nitrate with the silver. Hopefully that makes sense. So since there's only one silver with the nitrate and the nitrate's -1, the silver must be +1. So I know my silver is +1. So when I make it on this side, when I make a compound from it and chlorine, I assume that silver is +1, chlorine's -1, so I just need one of each. So my compound is written as AgCl. All right, now when I do the same thing with my barium that replaces the nitrate, it's going to go here. My barium is a +2 charge on the periodic table. The nitrate is a -1 charge. You would require 2 nitrates for every 1 barium because you have a -1 on each nitrate. So I'm going to write this as BaNO3 with a 2 down here, just like so. All right. Let's balance the equation. It looks like you can think of nitrates. You have 2 nitrates here, so we need 2 nitrates here. Put a 2 in front of there. That gives you 2 silvers. To put a 2 in front of there, that gives you 2 chlorines, and that's actually 2 chlorines. So we are balanced. That equation is written, whoops, and balanced as it is. The last one is combustion. This is the easiest one to write because combustion will always have the same products. The 2 products will always be CO2 and H2O. These will always be the products of a combustion reaction. All right, so what you'll do here is really balance the equation. You have 4 carbons, put a 4 here, 8 hydrogens, put a 4 here. That gives me 4 oxygens plus 8 oxygens, that's 12 oxygens, so put a 6 here, and the equation is balanced. Okay, so I have the same thing for you to practice on your own in this practice 11, and then we'll do a bunch of these in class. This is probably a tougher idea, so we'll take a few days to make sure we work through these, but go ahead and try to give the products and then balance the equations at the end. This completes for us the video.